Hey, this is HansPerm. So welcome to my video, and today we're going to have a run-through solve in one of the common shapes that we might be seeing in big cubes, but we might not rather notice it on a 3 by 3 cube, particularly on the edge flip. Since normally for a 3 by 3, we know that this the edge here, and this would be our corners. But when it comes to 4 by 4, so we have a couple of blocks there. This is considered to be the edge, and this will gonna be the corners. In a 5 by 5, of course, this is a 3 piece of block there for this edge, and these are the couple of corners. In a 6 by 6, we have also 4 piece of blocks there for the edge, and then a couple of corners. And for the 7 by 7, of course, we have 5 piece of blocks there for the edges. So the more our cube is getting bigger, of course, there will be much more combination of the edge, particularly when it comes to big cubes. But rather when it comes to a typical 4 by 4, this edge definitely could not, this is not supposed to be flipped. So something else or something wrong with the piece of cube if this two are flipped. But normally this is one set of example. If this were gonna be flipped, both of this, either those blue on the top and the white will be here on this face, right? But when it comes to 5 by 5, right, low edge, we're gonna be here in the middle, and a small piece of indexes over here. We might be facing yellow over here, and this would gonna be facing on the top here with the yellow, just like 0, 1, 0, right? Similarly, also with 6 by 6, of course, we could have this one piece, also one edge index here, and this couple of edges will gonna be in a different facing direction. Suppose this is yellow over here and green, and this one is yellow, and this is green, so it's 0, 1, 0, right? So either the way, probably this one is also yellow facing on here, or maybe this index will be here, the facing yellow, and then on the top green, right? So similarly also when it comes to 7 by 7, we could have this pair as well, right? So this one, this piece will be there, right? And of course it's much more combination here, that this will gonna be 0, 1, 0, 1, 0, right? Similarly also here, this would be also like that one, but that will be only a pair of index over here, right? So let's start with a 3 by 3. So I will gonna be working with a typical algorithm of a flip edge on typical big cubes. You don't notice that this is already an OLL, basically. If we're gonna be performing that one in 4 by 4, so say for example I'm gonna be performing that one in 4 by 4, yeah, it's a typical OLL, right? So this is basically the first flip that we might be seeing, either this flip and the corner is also flipped, right? But basically what we do in 3 by 4, we just perform this one in a typical OLL, right? Even similarly for this one, right? But the real flip now, we will see it later a bit. See, I'm performing the typical flip algorithm in a large cube as well. Right, now, say, I'll be working now on a flip, right? Say in a 4 by 4, this is normally happens during the OLL edge parity. This is what we call this one as. Everything else are been flipped. This is the edge and the corners as well, right? Of course, I cannot perform it here because there's only a single block piece here. It's an odd number, so when it comes to even number, we can perform that one, right? So this is basically now a real OLL parity, or what we say, it's a fledge edge, it's been flipped, right? If I'm gonna be performing that one in in a 5 by 5, of course, we have this one is an odd number, so I'll be performing a different algorithm here with the white turn here, R2, and later on with this one, R3. Right, but I'll do it here in even number, which is 6 by 6. Okay, so let's perform it in 6 by 6. Right, now you can see that these both the even numbers are now literally the same, so both all of these edges are been flipped along with those couple of corners there. Right, now if we're gonna be seeing it in a typical odd numbers, right? So definitely because of this middle edge, and similarly to this middle edge, right? So now let's see how a typical flip edge will be in a 5 by 5. So this will be having this algorithm with a white turn, couple of different white turns are there, right? Now you will see now our edge have different indexes here, like 0, 1, 0, right? So this is now literally also one algorithm that we are performing it in case on a flip edges, and of course this is a 3-piece block. We're expecting that there will be combination of these, right? And furthermore, of course, we will see that one later on if we will perform it in a 6 by 6, right? So if I will going to perform the same thing there, 1 minute, using a 4 by 4, right? So probably I'll start here, right? This one first white and second, and yeah, it's coming back. It's basically coming back on a typical OLL, right? So which means this is not applicable for this combination of this edge flip, right? So furthermore, of course, we're going to be working on that one. You don't perform a typical algorithm of flip edge. You will just do an OLL, right? Now let's see it here in a bigger cube, right? So I started here in this white, and right, let's fix this one first. Alright, and I'll be working on this flip edge using this 6 by 6. Probably I used 2 white R here. Right. First white is 2, and this white, and back to this 2 white R. Right, so there you go. So you see now the combination of 5 by 5 and 6 by 6. So this comes with 2 pieces of block, and this one is only single block, right? Because it's only 3 pieces of blocks. And similarly, of course, these 2 indexes, of course, having now the same facing, right? And let's see how it looks like when it comes to a typical 7 by 7. If I'm gonna be doing a couple of R wide turn here, of course I will be getting the same piece, and I'm expecting the middle index will be 3 pieces. So let's do that one. Right, 2, and there you go. So you can see now that almost the same, but only the indexes are increasing, right? Middle indexes of our flip edge is 3 pieces of blocks here in a 7 by 7, 6 by 6, 2, and of course here is 1. So we cannot perform it here, right? So let's solve that one once again, and started in 5 by 5. All right, there you go, and solve this one now. Similarly also here. Right, now, so this time let's see a different combination of edge flip. Okay, now this time let's go back with a different combination of a 6x6 when it comes to flip edge. Okay, let's go back on the first algorithm that we have learned. That everything else are been flipped, right? So we have seen that one in 4x4, and we can also perform that one of course here, but only on the middle edge, having a middle block there, right? So this is now a typical all flip edge that comes along with the two corners, right? That it started with a middle R wide here, yeah, which is also applicable to our 4x4, right? So let's solve this one once again. Right, so this time I'll be performing what we have learned on a 5x5, which is using first couple of R2 here, R wide 2, couple here, and then later with 4 piece here. This one, and there you go. Right, so this is now the second combination that we are seeing in a typical 6x6. Of course, this middle index here definitely should be the same facing colors on the top and here on the front. So this cannot be possible with the different flips here. Otherwise, something wrong with your positioning, right? But only that might happen only in a 7x7, right? So this is the last combination that we might be having only in a 6x6. But when it comes to a 7x7, there's still one more, right? So which means in a 5x5, we have a combination of 0, 1, 0, right? Here, 0, 1, 0 is also there, but the full piece here can be also be flipped, right? Now, solve this one once again. There you go. All right, so this time let's see the combination of edge parity when it comes to a 7x7, but we cannot start it with the middle one, but we could start on the way we have done it in a 5x5. So this one gonna be the first one, and second L wide, which is 2, and the rest thing, right? So let's start with this here. Alright, so this is the first flip edge that we'll be seeing, and this is like on this index there are 3 blocks here, and like a typical 0, 1, 0. Alright, solving that one, that is the first part of doing in R2, right? So let's put it back once again, solve this one. Alright, okay, second combination of our edge flip when it comes to 7x7 using this R, right? So let me perform this one. There you go. So you can see that it's a typical 0, 1, 0, but the middle index will be a single block, and a couple of these two rings on the sides are a couple of blocks then, right? So this combination is basically the second flip for a huge big cube like a 7x7, and actually there's still one more. Hopefully I could remember that algorithm, and everything else will going to be in different position. This is 0, 1, 0, 1, 0, but let's solve this one first. I'll be trying to work on that one now. Okay. Basically, the third shape for flip edge when it comes to 7 by 7 is look like this. So everything else on all the edges are flip. This is like 1 0 1 0 1. So this is what we call a double cycle. To solve this one is pretty much, of course, we could do similarly the same thing also here with a 5 by 5. Yeah, this one. And imagine that we're solving this one and we're going to compare to this, but there will be another uh, part here which is another combination. So I'll be using the same algorithm and you will see how it was called as a double cycle or double parity. Right, I'll be solving the same algorithm which I have done it in 5 by 5, and you can see that it came to this, right? So this is now another algorithm that I'm going to be solving so that I can also solve this one as complete edge now, right? I will perform that one with the same way in the 5 by 5. Right, and let's do the same thing also here. And there you go, right? Though there is another algorithm for straight away you can solve the double cycle instead of doing the double cycle, and that will come with a different algorithm, right? So anyhow, so that would be it. So thank you very much for tuning in.